Part 3 of Unit 1 is basics about the periodic table. The periodic table was first proposed by Dmitri Mendeleev in the 1800s. He was a Serbian chemist with an awesome beard. His periodic table was based on increasing atomic weight. Elements were ordered based on how heavy they were. He did not know about all of the elements that we know about today, so he actually left blank spaces in his periodic table where he predicted elements that were not discovered would fit in, and it turns out he was actually right. Here's a picture from 1869 of one of his early periodic tables. It's got the same basic order and organization as the modern periodic table, similar columns and rows, with elements in similar locations. But you can see we've got some blanks over here on the far right side. This is the bunch of metals that need to be shifted over. But for being in the 1800s, he actually had a pretty good idea of how the periodic table should work. The modern periodic table, instead of being arranged in order of increasing mass, it's arranged by increasing number of protons. The columns of the modern periodic table are called groups or families, and the rows are called periods. That's where periodic table comes from. And similar elements are grouped together, elements that have similar properties. So this is the modern periodic table. Go ahead and get yours out. We're going to be making some notes and marking yours up. You can see we've got the 7 rows of the periodic table, hydrogen down through francium here. These two down here, the lanthanides and actinides, they actually fit in to where this star and double star are. But the periodic table is usually shown like this just to keep periodic tables from taking up entire sides of buildings. So it's really just for space organization. There are 18 columns to the periodic table. Hydrogen is the first one, 2, all the way over to this one that starts with helium. This is the 18th group, so you may want to go ahead and number those. There's actually names for some of the groups on the periodic table. We're going to pretend that hydrogen is not connected to lithium here, because we know that hydrogen's a gas. That way, this name makes sense. Lithium down through francium is called the alkali metals. Hydrogen can't be a part of that. It's not a metal. Group 2, beryllium down through radium, is the alkali earth metals. This entire block of metals here in the middle of the periodic table, that's called the transition metals. Group 13, that starts right here at boron. It's got an incredibly boring name. It's called the boron family. 14 is the carbon family. The one that starts with nitrogen, group 15, it's called the pnictogen, spelled Pnictogen. So not nitrogen family, but the pnictogen family. Group 16 starts with oxygen. That's the chalcogen family. Chalcogen. Group 17 starts with fluorine. That's called the halogen family. And group 18 is the noble gases. There are 7 elements that we need to pay special attention to on the periodic table. Hydrogen's one of them. And all of these elements that make a 7 over here, nitrogen, oxygen, fluorine, down through iodine, back up there. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine are called diatomic elements. Diatomic means that we're never going to see one hydrogen or one fluorine atom by itself in nature. They're always going to bond to another hydrogen or fluorine, so it'd be H2, F2, Cl2 instead of just one chlorine. Those are the diatomics. Make sure you know those. There's an important line on the periodic table. Starts over here next to boron and zigzags its way through the periodic table. Everything on the left side of the periodic table, so most of the elements on the periodic table, are called metals. Everything on the right side, those are the nonmetals. Those elements that touch this line, those are called the metalloids or semimetals. They've got some properties of metals and some properties of nonmetals. There's a useful pattern on the periodic table that will help us remember the charge of ions. If we start over here at group 1, everything in group 1 tends to form a cation with a charge of +1. That means they lose 1 electron. Everything in group 2 forms cations with a charge of +2. That means they lose 2 electrons. The transition metals are special. Many of them have multiple possible charges. They're all going to be positive charges because they're metals, but there's not a nice pattern for them. So we're going to skip over to the boron group. All of these form cations with a charge of +3. The carbon group, they form ions with a charge of plus or minus 4. So +1, 2, 3, 4, when you get to carbon, that's going to be the highest. Going to nitrogen, these all tend to gain electrons because in ionic bonds, metals donate electrons to nonmetals. They're actually going to be anions with negative charges. So the nitrogen group has a charge of -3. Oxygen's group forms ions with a charge of -2. The halogens form ions with a charge of -1. And the noble gases, you can put a 0 above them. They don't form ions because they have a full valence shell of electrons. In case you forgot what a valence shell is, it's the outermost shell of electrons. Those are that are on the outside of the atom that can be shared. Noble gases have a full shell. They don't want to gain or give up any electrons. The reason that other atoms are combining with each other and sharing or donating electrons is they're trying to get a full valence shell of electrons. There's a pattern to help us remember the number of valence electrons that atoms have, and it's real similar to that charge pattern. Everything in group 1 is 1 valence electron. Group 2, 2 valence electrons. Again, we're going to skip the transition metals, but we're going to come over here to the boron group again. These all have 3 valence electrons, 4, 5, 6, 7, and 8. We say that 8 valence electrons is a full valence shell. That's sometimes called the octet rule. Your question for this section: what is the element in the 4th period of the halogen family, group 17?